Hello amigos, this is solving the quadratic equations which is involving a modulus function. Basically what he is asking is squares of the roots of the equation. First equation is mod x minus 2 whole square plus mod x minus 2 minus 2 is equal to 0. This is the first equation. At the same way we will also find the roots of the second equation. Let us understand about the first equation. Now this equation is not a simple equation in quadratic. Even though it doesn't look like a quadratic equation, if you observe it properly, it is a quadratic equation. Sir, what are you talking, sir? I am not understanding how come it is a quadratic equation. I will tell you. Let us suppose we make a simple substitution of mod x minus 2 is equal to t. How is the equation getting converted into? The equation getting converted into t square plus t minus 2 is equal to 0. Now we know how to solve this equation. This is a quadratic equation. This is a simple quadratic equation. Everyone knows how to solve this quadratic equation. Now factorize the quadratic equation. So the factors would be 2 comma minus 1. So that would be t plus 2 into t minus 1 is equal to 0. So that is t is equal to minus 2 or t is equal to 1. Now let us understand, our intention is to find the roots of this equation. So what do you mean by the roots of this equation? The values of x are nothing but roots of this equation. So when I get t is equal to minus 2, what did I take t as? I took t as mod x minus 2. So this t is mod x minus 2 is equal to minus 2. What is the meaning of this? Modulus of some function is negative of a number. Can the modulus be negative? No, it is not possible. So is it a valid solution, or can we get a valid root from this equation? No, we cannot get a valid root. Now let us solve t is equal to 1. What is t? Mod x minus 2 is equal to 1. Let us, if mod dabba is equal to a quantity a, which is a positive quantity, then dabba can be either plus a or minus a, which is nothing but dabba is equal to plus or minus a. Now in the dabba I have x minus 2. So mod dabba is equal to plus 1. So if I have mod dabba is equal to 1, I can have dabba is equal to plus or minus 1, which is nothing but x minus 2 is equal to plus or minus 1. Now which is x minus 2 is equal to either plus 1 or x minus 2 is equal to minus 1. So if I find out the root, x equal to minus, this will be 3 from the second side. So that is x is equal to 1. So I have a root which is x is equal to 3 and x is equal to 1 are the roots of the first equation. So I am right square plus mod x minus 2 minus 2 is equal to 0. What are the roots of this equation? One root, x is equal to 3 is one root. Another root of the equation is x is equal to 1 is another root. Okay, we are done with that. Now let us solve the second equation, that is x square minus 2 times of mod x minus 3 minus 5 is equal to 0. Now let's find out the roots of this equation. Now the problem with finding out the roots of this equation is we don't have a simple function, that is there is a function which is mod x minus 3. Unless we break the modulus function, we cannot find the roots of this equation. So let us understand a little bit more about modulus function. What is a modulus function? Modulus function is dabba. Modulus of dabba is plus dabba when whatever the quantity inside the dabba is a positive quantity, delta greater than or equal to 0. It is minus dabba when whatever the quantity inside the dabba is less than 0, that is negative quantity. So here if I wanted to understand mod x minus 3, so in the dabba I have x minus 3, so this will be plus x minus 3 when x minus 3 is greater than or equal to 0, that is in turn nothing but x greater than or equal to 3. That mod x minus 3 will be minus of x minus 3 when x minus 3 is less than 0, that is in turn x less than 3. So to understand about mod x minus 3, I have two cases. Case 1 is when x is greater than or equal to 3. This is case 1. So x greater than or equal to 3. Case 2 is when x is less than 3. Now when x is greater than or equal to 3, mod x minus 3, whatever is in mod x minus 3, that should be replaced by plus x minus 3 here. So mod x minus 3 will become plus x minus 3. So take the original equation, that is x square minus 2 times of mod x minus 3 minus 5 is equal to 0. So in place of mod x minus 3, replace with x minus 3. X square minus 2 times of x minus 3 minus 5 is equal to 0. So that will be x square minus 2x plus 6 minus 5 is equal to 0. Now x square minus 2x plus 1 is equal to 0. If you solve the equation, it will get a repeated root, that would be x minus 1 into x minus 1 is equal to 0. So x is equal to 1 is the root. Always and always remember that whenever you are dealing with modulus functions, always check that whether whatever the root you got, that is a valid root or not. Is the root satisfying the case which you have taken? So x is equal to 1, is it satisfying the case which you have taken? The case which I have taken is x greater than or equal to 3. But is your x is equal to 1 greater than or equal to 3? No, not at all. So x is equal to 1 is not a valid solution. Now we understood that from case 1 we are not getting any valid solutions. So let us go to case 2 and understand if you are getting a valid solution or not. Now in case 2, which is x less than 3, modulus of x minus 3, modulus of x minus 3 will become minus of x minus 3. So mod x minus 3 will become minus of x minus 3. Replace mod x minus 3 with minus of x minus 3 in the original equation. That is x square minus 2 times of minus of x minus 3 minus 5 is equal to 0. This is x square minus into minus plus 2x minus 6 minus 5 is equal to 0. So that is x square plus 2x minus 11 is equal to 0. First of all, let us try to solve the quadratic equation. That is, what is the discriminant? Discriminant is b square, that is 4 minus 4a 1 into c, that is minus 11. So that is 48. Yes, it is greater than 0. So we will have two roots. So what are the roots of this equation? The two roots of this equation are x is equal to minus b, that is minus 2, plus or minus square root of b square minus 4ac, that is discriminant, that is 48. 48 by 2 into a is 1, so 2 into 1, 2. So that would be, so x is equal to minus 2 plus root 48 can be written as 12 into 4, root 4 is 2, so 2 root 12 by 2. So we understand that 2 gets cancelled, so minus 1 plus or minus root 12 plus root 12. Another root I got is minus 1 minus root 12. Now let us understand if at least one of the root is valid root, or none of the roots is valid, or both the roots is valid. Sir, how can I understand that whether the roots are valid or not, sir? Simple. Are these roots satisfying the original case, that is x should be less than 3? Now how to understand, sir? I don't know root 12. So roughly try to guess a value of root 12. Root 12 is between root 9 and root 16. That is, root 9 is 3, root 16 is 4 somewhere. So you take 3.5. So first root approximately is minus 1 plus 3.5, which is 2.5. Is your 2.5 satisfying the case 2? Original case less than 3? Yes, 2.5 is less than 3. Yes, this root is correct root. What about minus 1 minus root 12? That is minus 1 minus 3.5, which is minus 4.5. Is it satisfying the original case? That is yes. Is your x less than 3? Yes. Minus 4.5 is less than 3. So minus 1 plus root 12 and minus 1 minus root 12, both the roots are correct. So second equation roots, that is x square minus 2 times of mod x minus 3 minus 5 is equal to 0. What are the roots I got? First root is minus 1 plus root 12. Second root is minus 1 minus root 12. Now what is the question? The question is the sum of the squares of the roots of the equation. So first equation roots are 3, 1. What is what are the sum of the squares? Squares and do the sum, and plus sum of the squares of the roots of the second equation, that is minus 1 plus root 12 whole square plus minus 1 minus root 12 whole square. So 3 square plus 1 square is 10, plus you can write it as root 12 minus 1 whole square. If you take minus cancel, minus whole square is plus, so you can write root 12 plus 1 whole square. This is kind of a minus b whole square plus a plus b whole square, which is 2 times of a square plus b square, or just simply expand it, you will get the same answer. So that is 10 plus 2 times of a square. So root 12 whole square plus 1 whole square. So that is 10 plus 2 times of root 12 whole square is 2 plus 1 whole square is 1. So 10 plus 2 times of 12 plus 1 is 13. So 10 plus 26, which is 36. So 36, which is option C, is the correct answer, which is 36. What is the understanding from this question? The understanding from this question is, whenever you get a quadratic equation in modulus linked questions, always split the quadratic accordingly as mod dabba is equal to dabba when dabba is positive is minus dabba when dabba is negative. Now after splitting the quadratic equation, now solve the quadratic equation, and always remember that after solving, whatever the root you got from solving, is it valid root or not? Is it satisfying the cases that dabba is greater than or equal to 0, whatever the particular case is there, is it satisfying or not? Just check. If it is satisfying, that is a valid root. If not satisfying, not valid root.